In this video, we'll evaluate the integral of 1 over x times 1 plus x squared with respect to x using substitution. A substitution will help us simplify this integral and make it easier to solve. To approach this integral, we have to identify a substitution that will simplify the expression. Notice in the denominator, we have x times 1 plus x squared. We'll take advantage of this by letting u equal 1 plus x squared. Next, let's find do by differentiating with respect to x. This gives us do equals 2x dx. Now our original substitution is still valid, but we need to rewrite it in terms of do in order to substitute it into the integral. For simplicity, we'll solve for x dx in terms of do. Rewriting, we have x dx equals do over 2. We can now use this expression to substitute into our integral. Substituting everything back to the integral, we'll replace 1 plus x squared with u, and x dx with do over 2. The integral now becomes 1/2 times the integral of 1 over x u times do. Unfortunately, this new substitution doesn't make much progress onto solving our integral. Let's take a step back and instead split our integral differently. With the integrand as 1 over x 1 plus x squared, we'll break it down as 1 over x minus x over x squared plus 1. This breaks our integral into two separate pieces. Now we have two separate integrals to solve, the integral of 1 over x and the integral of negative x over x squared plus 1. Let's solve the first integral on its own. The result is the natural log of x plus c. For the second integral, we'll use the substitution we originally planned. We replace u with x squared plus 1 and do with 2x dx. This simplifies to negative 1/2 times the integral of do over u, which results in the natural log of the absolute value of u, plus another constant c2. Simplifying further, this equals negative 1/2 of the natural log of x squared plus 1 plus c2. Finally, summing the two integrals gives us the complete solution to our original integral.